stark desolation or breathtaking beauty. The planet Mars offers both at once, and much more. No other world has so captivated human imagination, and apart from Earth, no other planet has been more closely examined or studied. Yet Mars continues to defy our expectations. And the closer we look, the more we realize we barely know Mars at all. The act of exploring another world is a plunge into the unknown. But Mars is different. So many spacecraft have been sent there that by now its major features are as familiar to scientists as the continents of the Earth. Today, the real unknowns on Mars are found at a smaller scale, a human scale, and exploring them takes a keen eye for detail. Today, there's no keener eye on Mars than the one that belongs to MRO, the Mars Reconnaissance Orbiter. Like a great bird scanning for prey, MRO soars over Mars with its solar panels outstretched, using the most powerful camera ever sent to another world to peer down at the alien terrain passing below. As it orbits from pole to pole, MRO scans the surface, creating images in long strips that are only a few kilometers wide, but could stretch to well over 100 kilometers long. Within these narrow strips, MRO's sensitive camera can perceive features as small as a dinner plate. That's many times sharper than any previous spacecraft has ever seen Mars from orbit. And it means that MRO is the first orbiter with the power to connect the Mars we see from space with the Mars we wish to explore on the surface. Painted in false color images that are chosen to bring out interesting features, MRO's views of Mars are views at the level of local geography. But taken together, the small-scale details they reveal help to tell a very big story, both about the planet's current conditions and the ancient processes that produced this astonishing landscape. And because those processes involved heat and water, it is also possible that billions of years ago, they enabled the emergence of life on Mars. If life once did gain a foothold here, the evidence is buried under layers of Martian rock, layers that MRO can discern better than any other orbiting spacecraft. In fact, MRO has turned Mars into a planet of layers, allowing scientists to explore Martian history as though it were the skin of a giant onion. MRO has also shown Mars to be a planet sculpted by wind, where fine-grained dust can form vast fields of dunes that gradually migrate across the planet. The dunes of Mars are spectacular, rippled masterpieces that remind us of nature's power to create and destroy entire landscapes one sand grain at a time. With their shifting, sinuous features, the dunes bring Mars to life, revealing the dynamic nature of its surface. But the wind can also create phenomena that are much more fleeting. In many regions of Mars, MRO has found dark streaks crossing the plains, like scribble marks from a giant pen. These are the tracks left by dust devils, wispy whirlwinds that traipse across the surface like miniature tornadoes, scouring the rock clean of dust as they go. Dust devils are so common on Mars that MRO has captured several of them. Here, one twists serpent-like above the plane, casting a long shadow that reveals the dust devil is nearly a kilometer high. Elsewhere, there is a different kind of evidence that Mars can be the scene of dramatic action. Here, the spacecraft examines a crater that was not present in a 2009 photo, but appeared in 2011. In false color, the freshly excavated debris of the blast looks bright blue against the dusky surface. These fresh impacts are not just curiosities. The material they expose provides clues to what lies just below the Martian surface. And sometimes they can even expose a hidden layer of ice, the frozen remains of Mars's warmer, watery past. MRO has also seen plenty of ice sitting on the surface of Mars, but this is dry ice, made up of frozen carbon dioxide rather than frozen water. As it comes and goes with the seasons, the dry ice can take on a fascinating diversity of forms, sometimes appearing as though painted on the Martian surface by an artist with a flair for the improbable. And sometimes the view of a Martian polar terrain covered with dry ice can even seem to resemble bacteria under a powerful microscope. So powerful is the eagle eye of MRO that it has even been used as a telescope to look up at the two moons of Mars, Phobos and Deimos, as they orbit high overhead. These moons may someday serve as outposts, where human astronauts arrive before descending to explore interesting sights on the planet below. By then, the surface of Mars will have been scouted and sampled by a new generation of robot explorers. And those robots will be looking to MRO to tell them where to land. On the smooth slopes of Pavonis Mons, a giant Martian volcano, the Mars Reconnaissance Orbiter makes a startling discovery. A small crater, alone on the featureless landscape, appears to have a strangely dark center. Looking more closely, MRO finds that what seems like a crater is really a natural skylight, where part of a volcanic formation has collapsed, exposing a hidden cave below. This remarkable picture invites the tantalizing prospect of someday entering the cave and exploring Mars beneath the surface. But falling into such a hole unexpectedly would spell disaster for a rover on Mars. And that's why orbiting missions are used to spot both the hazards and the opportunities on the Red Planet. When it comes to Mars, every orbiting spacecraft has two jobs. The first is to explore the entire planet from above, gathering the clues that researchers need to put together the story of the Red Planet on a global scale. The second job is to pave the way for exploration on the surface of Mars by finding the perfect place to land. With its high-powered view of the surface, MRO has played a key role in the planning of missions to land on Mars, offering more information about potential landing sites than once was ever thought possible. In the history of Mars exploration, this is still a recent development. In fact, two of the best-known Mars explorers, NASA's Spirit and Opportunity rovers, had already been working on the surface for years before MRO arrived. Amazingly, MRO's vision is sharp enough to spot the rovers on the surface, although each is not much larger than a wheelbarrow. Here, the orbiter zooms in on the rover Spirit, which gleams brightly as sunlight reflects off its solar panels. Meanwhile, over on the other side of Mars, MRO finds Opportunity perched on the rim of Endeavour Crater. With a diameter of 22 kilometers, this is the largest feature Opportunity has explored to date. It headed this way after MRO saw evidence for minerals related to water in its orbital view of the crater. Soon after MRO reached Mars in 2006, it had its first assignment helping a surface mission find the best landing site. The mission was Phoenix, a lander designed to touch down in the north polar regions of Mars and probe for the permafrost believed to lie just below the surface. Prior to MRO's arrival, mission planners favored an area known as Region B for Phoenix's landing site. But with their improved view from MRO, they found that Region B was full of boulders that would have spelled disaster had the lander set down on one. Instead, a backup landing site was chosen, and Phoenix landed safely in May of 2008. Soon after, MRO was able to confirm the lander's position by imaging it from space. For the first time in history, a landing on Mars had come with its own eyewitness. The next mission to Mars was to be much more complicated. Instead of a lander, NASA had decided to send another rover to follow up on Spirit and Opportunity's impressive finds. This newer and much larger rover was to be the most sophisticated probe ever to set down on Mars, an entire mobile laboratory. And it might be the first to determine if Mars once had conditions suitable for life. And with only one rover to land, there would be no second chances. MRO set about scouring the planet, helping pinpoint geologically interesting locations. As with earlier missions, high priority was given to places where there is evidence for past water flowing on the surface of Mars. Starting with a list of more than 60 candidate landing sites, scientists began a detailed 5-year investigation to find the best possible location for the next rover on Mars. Using data from all available orbiter missions, but relying especially on detailed views from MRO, scientists managed to narrow the list to 4 finalist sites by the spring of 2011. Among them were some of the most intriguing and geologically complex places on Mars. Places such as Holden Crater, an ancient formation that was turned into a vast lake when a channel carrying floodwaters breached the crater rim. Just north of Holden is another candidate site, Eberswald Crater. It also shows signs of past flooding, But here, the key feature is an ancient river delta at one end of the crater. A very different kind of landing site presents itself at Mars Vallis. Billions of years ago, this channel drained a torrent of water from the Martian highlands in the south to the low-lying northern plains. All three of these sites show terrific potential for uncovering the history of water on Mars. But in the end, scientists chose a fourth site, a site that combines some of the most attractive features of all the others in one location, and adds a mysterious mountain that could unlock the secrets of ancient Mars. After more than 40 years of interplanetary exploration, Mars has offered some of the most spectacular sights in the solar system, from huge volcanoes to deep chasms to the beautifully sculpted layers of ice and dust that cover the Martian poles. But among its many diverse and intriguing features, there is nothing on Mars that looks quite like this: a giant mound more than half the height of Mount Everest, sitting squarely in the middle of an ancient impact crater. This is Gale Crater, a formation that has long attracted interest and speculation from Mars scientists. It's also the landing site of the most ambitious mission ever to touch down on the Red Planet, NASA's Mars Science Laboratory, better known as the Curiosity rover. Compared to previous rovers, Curiosity is built like a tank. The size of a small car, it weighs 900 kilos and carries 10 separate scientific instruments for the detailed testing of the rocks, soil, and atmosphere of Mars. But most importantly, Curiosity is powered by a device that generates electricity from the radioactive decay of plutonium. Curiosity's nuclear power supply would give it the potential to explore Mars for years, allowing scientists to select a more ambitious target. And few features on Mars are as scientifically interesting as the mountain in Gale Crater. Nicknamed Mount Sharp after a pioneering planetary scientist, this strange formation rises above everything else around it, including the rim of Gale Crater. Closer inspection by the Mars Reconnaissance Orbiter has revealed that the mountain is really a pancake stack of sediment, whose lowest sections are made of clay layers that formed in the presence of water. Those layers could well be a gold mine for scientists because they represent a slice of geologic time that spans over 100 million years of the most crucial period in Martian history. A time when Mars may have shifted from a habitable planet to a frozen desert. By July of 2011, Curiosity's fate was sealed. NASA announced that their new rover was destined to become a mountain climber.
3, 2,
the rover would be sent to Gale Crater.
And liftoff.
Now, it just had to get there in one piece. After years of planning and an 8-month journey from Earth, the moment of truth arrived on the night of August 5th, 2012. Nested safely in its protective capsule, Curiosity jettisoned its cruise stage and, drawn by the planet's gravity, began its terrifying plunge. Soon, friction with the thin Martian atmosphere began heating up the front of the capsule to a peak temperature of over 2,000 degrees Celsius. Now, still traveling at over 1,400 kilometers per hour and just 11 kilometers from the surface, Curiosity deployed its parachute. 15 seconds later, the heat shield fell away, revealing the rover tucked inside. But now, the rover was still falling fast when it separated from its parachute and back shell and ignited 4 powerful descent rockets. But how exactly to land? Separating from its descent stage, the rover was lowered to the surface on 3 nylon cables. As it touched down, the cables were cut and the descent stage veered off, crashing to the surface a safe distance away. And then came the signal. Curiosity is the 7th mission to land successfully on Mars, but it's different from all its predecessors in a crucial way. It is the first Mars mission to combine the mobility of a rover and the scale and complexity of a field laboratory with the potential for operating for years on the planet's surface. That combination will change our understanding of Mars forever. This will be the longest journey ever attempted on another world, but it will not be as lonely. As Curiosity begins its epic trek across the surface, it will be watched from above by MRO, the eagle eye that has become part of day-to-day life on Mars, even as we look for signs of life in the past.